Hello, and welcome back to Joe Bailey's GCSE revision. Today we are starting our first topic on physics, which is waves. These are the 5 topics we'll go through today. They are required for the exam, which is coming up soon. Okay, so let's start this. Waves. Phys 1, waves. Some nice waves there, literal waves. So, let's start on waves. So what are waves? Well, there's 2 types of waves. This is a longitudinal wave, and this is a transverse wave. They're different as the longitudinal wave moves by vibrations, which are parallel to its direction, and certain parts of it are compressed together and then it's released apart. However, on the transverse wave, the vibration is at 90 degrees to the direction, and the wave only goes in one direction. Well, here the wave goes in one direction, but it goes backwards and forwards in a vibration sort of way, like a spring. So, as I said, it's vibrations and oscillations. So the first one, that is vibrations. So the longitudinal wave travels by vibrations, and the transverse wave travels by oscillations. And some things about waves, a vibration can't travel in a vacuum. It goes faster through solids, so that's some facts about longitudinal waves. So if it was going through a solid, it would be faster. The wave direction of both waves is that way. In this it's called compression, where they're close together, and refraction, where they're far apart. There are many points on a transverse wave: a crest, a trough, a wavelength, and the amplitude. The wavelength is just the distance between crests. The wider wavelength means the lower pitch the sound is. And the amplitude is basically the maximum displacement above or below the line, which determines the energy of the wave, which means the higher the amplitude, the louder the sound. Yes. So some examples of these types of waves. So transverse waves, put that there to confuse you, they're all wrong. Transverse waves, which are these ones, include water waves, here, seismic waves, which I'm pretty sure are like earthquake ones, type S, and all electromagnetic waves. So electromagnetic waves are light, gamma, X-ray, microwave, radio wave, UV wave. You might be asked if the shortest electromagnetic wave is the microwave, it's the light wave, which is 0.5 nanometers, I believe that is, or something like that. And then the radio wave is 3 kilometers. The microwave is 3 centimeters. So that's just some examples of that length. And then the longitudinal waves include sound and seismic waves type P, which are different from type S, and ultrasound waves, which is basically like sound but better. They're all longitudinal. So we've learned about how waves transfer energy, and now we're going to go on to frequency and time period and that stuff. So frequency is basically how many waves are produced in 1 second, and it's measured in hertz. Whereas time period is the time it takes for a wave to form. It's measured in seconds. There's an equation here. Just decided I'd make the equation more clear for you. T equals 1 over F, or F equals 1 over T. Is it rearranged? So if you're given the frequency and need to find the time period, then do 1 divided by the frequency. If you're given the time period and need to find the frequency, do 1 divided by the time period. Time period seconds, frequency hertz. 1 is just a digit you just automatically put in there. It's not a variable, it never changes. So let's get on to more things about waves, in particular light waves. So reflection. So the angle of incidence equals the angle of reflection in a plane mirror. So basically, if you hit it at one point, it will bounce back at the same point. Well, not the same point exactly, but the same degrees around as it's gone in. As we can see here, it hits at a certain point, then at the opposite side, it's gone around the same degrees from the middle and just bounces back. So what is a plane mirror? So a plane mirror is a normal mirror, and basically it's laterally inverted, it's virtual, it's the same way up, it's the same size, and there's the same distance away the object is, which basically means there's no magnification. So let's go on to refraction. So refraction is where a light wave changes direction as it goes from the air to the glass. This is as light waves change speed due to the density change. as the glass is a lot denser than the air it's come from. So this leads to the image appearing higher than the actual object is. So the brain just assumes it's a straight line, even though it's not. And so, total internal reflection, that's what this stands for. So that's basically where it just goes sideways off the top anyway. And that is if the angle of incidence is more than the critical angle. So, for glass, for example, that's 42. So if the angle going in is more than 42, it will just go straight like that. So another thing about waves that works for a lot of waves is diffraction. Just basically when waves go through a gap, they're spread out, and that looks sort of like the Wi-Fi symbol. So that's how you can remember it. Oh, what am I doing? Why are we doing this? So let's move on to everyone's favourite part of physics, the equations. So we've got some equations for this. So we've got the wave equation. Velocity, which is in meters a second, equals frequency, which is in hertz, times wavelength, which is in meters. So basically, you can find out frequency and the wavelength from this. So you find out the frequency from here by using the time period thing. If you're given the time period, or maybe you'll just be given the frequency as it is in hertz, and then you can find out the wavelength from the actual distance between the different crests. You can use that to find out the velocity. However, they could also link another equation here, which is speed equals distance over time. The way this works is that distance basically counts as wavelength, and time period, which is also in seconds, can also be used to stand for time. So basically, the speed equals the wavelength, which is in meters, divided by 1 divided by the frequency. So that's another way. That's the link between those two equations. So, okay, that was waves, including longitudinal waves, transverse waves, lots and lots of other waves, light waves, gamma waves, ultraviolet waves, gamma waves, sound waves, ultrasound waves, supersound waves, even better than ultra supersound waves. Okay, that was goodbye.